today's module is preservation of food by chemical methods. The main objective of this module is to enhance understanding of chemical preservatives for various food applications. Food can be preserved by various methods that allow it to be kept for a longer time along with retaining its nutritional quality by avoiding growth of spoilage causing microorganisms in food. The key objectives of food preservation are preventing the food contamination from the microorganisms and pests, hindering the growth of microorganisms in the food, and delaying of enzymic spoilage due to self-decomposition of food that occurs naturally by own enzymes. Hence, our purpose is to select an appropriate food preservation procedure which effectively manages the microbial content without affecting the nutritional qualities of food. To achieve this objective, there are several chemicals and natural compounds are available which may be added to food. The substances or a mixture of substances which may be added to the basic food stuff as a result of any aspect of manufacturing, processing, storing or packaging are called as additives. For example, vitamins, mold inhibitors, bactericides, emulsifiers, minerals, food colors, sweeteners and artificial flavors. Therefore, food additives are the chemical preservatives which added particularly for preventing the spoilage of food and inhibit the microbial growth. The chemicals which are especially added in food to prevent decomposition or deterioration are referred as chemical or intentional preservatives, while some chemical which get accidentally into food are termed as unintentional additives like unavoidable residues of agricultural chemicals including pesticides, weedicides and traces of antibiotics. Nowadays, some conventional methods for preserving food are practiced at domestic level, which can be categorized as chemical method like adding of salt, sugar, brine, vinegar, spices and wood smoke are usually considered as safe and natural preservatives. Particularly salting, sugaring and wood smoking are common method for curing food. The most chemical preservative inhibit microbial cells by interfering with their cell membranes, enzymic activities or altering their genetic mechanism, and other preservatives such as antioxidants, neutralizers, stabilizers. Antioxidant hindering or interfering the oxidation of unsaturated fats, neutralizers neutralizing acidity, and stabilizers preventing physical alteration in food, keeping out of microorganisms from wrappers, preventing loss of water or delay in undesirable microbial, enzymic and chemical reactions in the food. In general, preservatives extend the shelf life of food product and also protect them from microbial attack. As per the list, the preservatives are one of the 26 major additive categories which are used during the food processing and have been evaluated frequently and confirmed to be safe by regulatory organizations such as Scientific Committee on Food and European Food Safety Authority at maximum levels. Food preservatives may be natural or synthetic origin. The Canadian Food Inspection Agency CFIA grouped food preservative into 4 classes based on similarity in the microbiological or chemical activity of each class. Class 1 include curing preservatives for cheeses and meats. Class 2 includes antimicrobials which inhibits the activity or growth of microorganisms. Class 3 antifungals which inhibits the activity or growth of yeast and molds in food, and class 4 includes antioxidant and its synergists which are used to prevent the oxidation of vitamin, minerals, lipids of food, and anti-browning agent which prevent both enzymic and non-enzymatic browning of foodstuffs. An ideal antimicrobial preservative should have several attributes like it should have demonstrate broad spectrum of microbial activity so that wide range of microbes can be killed or destroyed. It should be non-toxic to handlers and consumers. The cost of production should be low.
and it is expected that it should not affect organoleptic properties of food to be preserved and should not be inactivated by food. Preservative should not promote the growth of resistant strain, and it should kill microbes effectively rather than inhibit multiplication.
There are numerous factors which affect the usefulness of chemical preservatives in the killing of microorganisms or inhibiting their multiplication and activities, such as the concentration of chemicals, kind, number, age, temperature, duration of exposure, and other physicochemical properties of the substrate in which the microorganisms exist. Therefore, extrinsic and intrinsic factors affecting the growth and survival of microorganisms in food must be taken into consideration while using them.
Antimicrobial preservatives used in food can be categorized into 4 groups. Group 1 include natural organic acids and their salts like vinegar, sodium chloride, sugars, spices and its oils, wood smoke, carbon dioxide and nitrogen. These added preservatives were not defined as such by laws. Group 2 includes substances having generally regarded as safe status for addition to food such as propionic acid and its salts, sorbic acid and their salts, benzoic acid and benzoates and its derivative, sulfur dioxide, sulfides, etc. However, some restriction on the use of few of them must be taken into consideration during their application. Group 3 includes certain chemicals considered to be food additives which are not listed in the first 2 groups, though they can be used only when proved safe in clinical trials for humans or animals, and later on they can fall into Group 4. Group 4 includes proved safe and approved by the Food and Drug Administration (FDA) from time to time.
Keeping in view of public health safety, all additives and preservatives must be approved by food regulatory authorities such as the Scientific Committee for Food, the European Food Safety Authority and the joint FAO-WHO Food Additives Committee, etc. before using them. Food additives and preservatives should be applied to at maximum level in accordance with the guidelines and recommendations provided by the concerned food regulatory authorities time to time. These recommendations were adopted by the government at a national and international level so that food can be preserved effectively and also ensure that safety of food for consumption.
Preservatives are intensely added to food to inhibit or kill microorganisms. The classification of preservative is based on various other criteria such as chemical composition and nature, mode of action, specificity, effectiveness, and legality.
Organic acids such as lactic acid, acetic acid, propionic acid, sorbic acid, benzoic, citric, caprylic, fumaric, malic acids, etc. and their salts either may be added or developed during fermentation process in the food. It has been demonstrated that undissociated form of organic acids penetrate cell membrane more easily than dissociated forms. Organic acids are inhibitory to foodborne pathogens including Bacillus, Campylobacter jejuni, Escherichia coli, Clostridium, Listeria monocytogenes, Salmonella, Pseudomonas, and Staphylococcus aureus. For example, citric acid is used as a substitute for adding flavors in fruits and for preserving drinks, jams, and jellies.
In this slide, you can see selected food preservatives and type of products they are used for with maximum permissible limits. The permissible limits for applying these food preservatives differ in every country with the kind of food products they are used. Propionic acid is a short chain fatty acid like some other fatty acids. Naturally, up to 1% propionic acid is produced in Swiss cheese by Propionibacterium species. Commonly, sodium or calcium propionate is most widely used for preventing the growth of molds and development of rot in baked products and inhibits mold in cheese products. Although its precise mode of action is not yet precisely known, but it might be affecting the permeability of cell membrane. However, the activity of propionic acid depends on pH of the food to be preserved. The effectiveness decreases with an increase in pH up to about pH 5 to 6. Although propionates are effective against molds with little or no inhibition of most yeast and bacteria, but in bread 0.1 to 5% concentration is added to prevent the growth of Bacillus subtilis, which is the bacterium responsible for ropinase. As the propionates have little inhibitory effect on yeast, therefore they can be mixed in flour to form dough of yeast raised product without affecting leavening. The sodium salt of benzoic acid has been used widely as an antifungal agent in food and very effective against Talaromyces pichia 0.1% level, pH 3.6 to 4, and reduces E. coli by 3 to 5 log in 1 week at 8 degrees Celsius. Although the effectiveness of benzoates ranges from pH 3 to 8, but most effective against yeast and molds at pH 5 to 6. The benzoates have been added to jams, jellies, carbonate beverages, fruit salad, pickles, fruit juices, etc. The mode of action of benzoates is still not clear. However, it is known that the effectiveness of benzoic acid esters increases with an increase in the chain length of the ester group, more effective against fungi and 2 gram-positive bacteria.
Salts of sorbic acid like calcium, sodium or potassium sorbate can be used as either direct antimicrobial additive in food or as a spray, dip or coating on packaging materials. The salts of sorbic acid extensively used in cheese product, baked product, beverages, syrups, fruit juices, fruit cocktails, jams, jellies, dry fruits and pickles. Sorbic acid and its salt prevent the growth of mold, yeast, but less effective against bacteria.
Acetic acid is a primary component of vinegar which can be used in the preservation of mayonnaise, pickled sauces and pig's feet. It is more effective against yeast and bacteria than molds. Acetic acid is more effective with a decrease in pH. The derivative of acetic acid are monochloroacetic acid, peracetic acid, dihydroacetic acid and sodium diacetate have been recommended as chemical preservatives. Sodium acetate is used for preserving mainly acidified food, refrigerated food, meat food products, and it controls pH. Scientists proved that 0.1% concentration of sodium acetate in bread, pH 5.1 and shelf life 6 days at 30 degrees Celsius inhibit the growth of Bacillus subtilis, and 1% concentration of sodium acetate increases shelf life of catfish by 6 days at 4 degrees Celsius. Sodium diacetate mainly used in malt syrup and cheese spreads and also used for the treatment of packaging wrappers of butter. Nitrites and nitrates are chemical compounds which occur in the environment naturally and considered plant nutrients can also be applied for preserving some specific food products. Usually, a combination of their salts has been added in curing solution for meat. Although these preservatives have been practiced for preserving food for hundreds of years, yet some researchers linked with certain kind of cancers. In general, nitrite decomposes to nitric acid and form nitrosomyoglobin with heme pigments of meat and provide a stable red color to the meat. Furthermore, Nitrites can react with secondary and tertiary amines to develop nitrosamines, which are known to be carcinogenic. They have shown the inhibitory potential to Clostridium botulinum and used for preserving meat products, especially in bacon and canned ham. Presently, sodium nitrate and potassium nitrate are most commonly used forms. As nitrate have a limited effect on few organisms only, therefore it is not considered as good chemical preservative.
The Egyptians and Romans burned sulfur to form sulfur dioxide to sanitize their wine making equipment and storage vessels or containers. Although they were used sulfur dioxide as disinfectants, in recent times wine industry is using sulfur dioxide and sulfides for sanitizing equipment and reducing the load of the normal flora of grape must. Salts of sulfur dioxide such as potassium and sodium sulfides are most widely used for preserving vegetables and fruits by controlling spoilage and fermentative fungi in wine, malolactic and acetic acid bacteria. The effectiveness of sulfur dioxide increases in aqueous solution as it forms sulfurous acid, which is the most active antimicrobial compound. There are several mechanisms of action of sulfurous acid on microbial cells have been suggested, such as reduction of disulfide linkages, the formation of carbonyl compounds, and inhibition of respiratory mechanisms. Sulfides are inorganic salts which have great potential as an antioxidant and preservative. They can be used to prevent discoloration or enzymic and non-enzymic changes in certain food.
Ethylene and propylene oxide exist in gaseous form. Unlike other chemical food preservatives explained, ethylene oxide is more effective than propylene oxide because it kills all microorganisms without increasing the temperature of food or materials to be treated. That is why it is called cold sterilization. Ethylene and propylene oxides are primarily used as sterilants to packaging materials and also applied as fumigants in warehouses, plastics, pharmaceuticals, and medical supplies and devices. Moreover, these are successfully used for preserving dried fruits, eggs, dried yeast, cereals, spices, gelatin, etc. Both gaseous sterilant considered to act as alkylating agent, attacking labile hydrogen, and successful in destruction of Clostridium botulinum, Clostridium sporogenes, Bacillus coagulans, Bacillus styrothermophilus, and Deinococcus radiodurans. The 500 to 700 mg per liter concentration of ethylene oxide is applied for sterilization of flexible and semi-rigid containers. Salt is one of the world's ancient food practiced for preserving meat and fish since ages. The food products can remain in good condition for several years treated with salt as it keeps food and microorganisms dehydrated. This practice, not allowing the microorganisms to decompose or spoil the food products, and also keeps food dry enough to restrict the growth of fungi by developing high osmotic pressure that leads plasmolysis of cells. However, the percentage of salt required to inhibit or damage the microbial cells is varying with the type of microorganisms. Normally, sodium chloride is added in brines and curing solutions or applied directly to food has been reported with these reactions. May ionize to yield the chloride ion that is harmful to microorganisms of food, may develop anaerobic environment by reducing the solubility of oxygen in the moisture and by interfering with the action of proteolytic enzymes. The effectiveness of sodium chloride varies directly with its concentration and temperature in which it is applied. Similar to salt, sugar reduces moisture from food and owe their usefulness as preservative by making water unavailable to microorganisms and their osmotic effect. There is sufficient evidence that sugar has been practiced for thousands of years as a preservative, as ancient Egyptians were known to preserve food in jars of honey. Usually, food products to be preserved in sugar are sweet and may be stored in sugary syrup such as honey or cooked in sugar until they crystallize. Sweetened condensed milk, fruits in syrup, candies, jellies, etc. are few examples of food preserved by using sugars.
Alcohol is an antiseptic which can kill microorganisms and used in the preservation of fruits. However, fruits will not keep all the desirable qualities as their sugars and flavor will dissolve in alcohol. Hence, sugar must be added to preserve. Normally, fruits preserved in flavorless spirit in large corked jars or sealed with glass lid and a rubber band. The most widely used alcohol is ethanol, which as a coagulant and denaturizer of cell proteins. The most effective germicidal concentration of ethanol is in between 70 to 95%. Ethanol is employed in the preservation of vanilla and lemon extract. Methanol should not be added to the food due to its poisonous nature. Propylene glycol has been used for inhibiting mold and killing airborne microorganisms by spraying in food processing area.
Formaldehyde is also known as methanol, which is a colorless gas with the pungent and irritating smell, extremely reactive and easily soluble in water. The pure formaldehyde is not available or marketed, while formalin, that is 40% solution of formaldehyde, is the most widely used as a formaldehyde containing solution. It is illegally practiced as food preservative because it can extend the shelf life of food by protecting against the spoilage causing microorganisms. Formaldehyde is not allowed except as minor constituent of wood smoke due to its effectiveness against a wide range of microorganisms like molds, bacteria and viruses, where its poisonous nature and irritating smell are not concerned. That is why it is suitable for the treatment of walls, shelves, floors or other surfaces to eliminate mold as well as their spores. Formaldehyde might be combined with free amino groups of proteins of the microbial cells and coagulates proteins. Hence, the addition of formaldehyde to food is not permitted except as a minor constituent of wood smoke, because this compound is very effective against wide range of microorganisms such as mold, bacteria and viruses can be used where its poisonous nature and irritating smells are not objectionable. Wood smoke contains numerous volatile compounds such as formaldehyde, aliphatic acids, primary and secondary alcohols, ketones, acetaldehyde, other aldehyde, waxes, resins, catol, methyl pyragalol and other methyl esters that may have bacteriostatic and bactericidal effect. Wood smoke is much more effective against vegetative cells than bacterial spores, and temperature varies with the type of wood used. This method is mainly practiced in preserving meats and fish that have undergone curing and for cooking or flavoring of certain fruits as well as vegetables. Moreover, ingredients for preparing drinks such as malt and tea leaves are also smoked.
Spices and condiments are vegetable products or their mixtures that are free from extraneous matter and used for flavoring, seasoning or imparting aroma in food. Although they do not have any noticeable bacteriostatic effect but may help other agents in preventing or suppressing the growth of microorganisms in food. Usually, an inhibitory spectrum of spices varies with the type of spice and microorganism being examined. For example, mustard flour and volatile oil of mustard are very effective against baker's yeast Saccharomyces cerevisiae, but are not effective as cinnamon and cloves against most of the bacteria. It has been confirmed that The essential oils of spices are more bacteriostatic than corresponding ground spices. For example, cinnamon containing cinnamic aldehyde and clove containing eugenol normally are much inhibitory than are the other spices.
The purpose of using additives in food is to enhance the keeping quality of food by increasing its shelf life. Some other food additives employed widely are halogens, which are mixed in water for washing food equipment, for chilling, and in addition to certain products. For example, bromine is used as food additives in flour and some fruit flavored soft drinks. Unfortunately, bromine may cause an adverse effect on thyroid gland. Usually, water intended for drinking purposes can be chlorinated by direct mixing of chlorine or hypochlorites or chloramine. These added halogens kill microorganisms by oxidation, injury to cell membranes, or direct combination with cell proteins of microorganisms. Phosphoric acid is added to soft drinks. Wrappers of fruits impregnated with iodine have been practiced to increase the keeping time of fruits. Iodophores, which are a combination of iodine with non-ionic wetting agent and acid, is being in practice for decontaminating dairy utensils.
In general, antibiotics are added in feed of cattle or in treating their diseases. Then, sometimes residues of antibiotics may occur in milk if cattle are fed on antibiotics. According to the Food and Drug Administration (FDA), that milk from such infected animals should not be used for human consumption for at least 3 days following the treatment of the animal with antibiotic. However, most of the well-known antibiotics have been examined on raw food, particularly on proteinaceous food such as meats, fish and poultry, to lengthen the storage time at chilling temperature as shelf life increases 2 to 3 times due to reduced growth of the microorganisms.
Aureomycin has been considered superior to other antibiotics examined due to its broad spectrum activity. Another antibiotic, terramycin, is almost as good for increasing the time of food preservation. Both aureomycin and terramycin have been used in cooling water for dressed poultry. Likewise, antibiotics are added in packing of raw fish and shellfish and later its cooking to destroy the antibiotic residues, making them safe for human consumption. Sometimes developed preservatives such as lactic acid, alcohol, bacteriocin such as niacin, which is a polycyclic antibacterial peptide containing 34 amino acid residues, as a food preservative produced by Lactococcus lactis, etc., could be produced in food by microorganisms.
Home and commercial scale food preservation is a very practical approach for making the best of available food. Several methods of food preservation are available nowadays. Chemical food preservation has been experienced ever since man first began to store food for later use. In general, food preservation raised the problem of spoilage mainly caused by microorganisms such as bacteria, fungi and yeast, making food inedible or unsafe for consumption because microbial activity could lead to potentially fatal food poisoning. From ancient times, a wide variety of chemicals have been employed to prevent microbial spoilage in food, and their use times from well before the point when the existence of microorganisms was first suspected. The criteria for successful food preservation is to prevent contamination by disease-causing microorganisms or toxicity through chemical, and maintenance of optimum qualities like organoleptic properties, color, flavor, texture and the nutritive value of the food.